should be seeing, not me, you should be seeing the notes. Are the notes up on your screen to be shared? Or is it just that picture of me? Oh, okay. Okay, thanks, James. Awesome. Okay, so let's go ahead and get started. Elijah asked me to do a couple problems from 4.6 and 4.8, which I'm completely good with. I also want to go over 4.9, which I think is going to be a really easy section for you guys, because we can use Desmos. So I don't know if we want to go ahead and start with the 4.9, and then I'm happy to go over any questions in all of chapter 4. So get your questions ready for those. Okay, so 4.9, number one, just to clarify, if it's not clear for you, it's 7 through 25 and 35 through 43, and that's all odd. So I guess it, wait, we had to do 9, we didn't do 4.9 yet. We're just doing it today. So if you don't have it for Monday for your homework, it's okay. If you need some more time. You've done it already? All right, so just to clarify, if my screen will let me write on here, this should say 7 through 25 odd and 35 through 43 odd. So that's just to clarify that. All right, so what we're going to talk about is to graph and solve quadratic inequalities. Okay, so this is as, I mean, if you were doing this offline, it would take a little bit of work, which you could totally do, right? We talked about being able to graph quadratic equations, and we would just do that by finding probably like 4 or 5 points on the quadratic and graphing it. So we could do that if we wanted to. We also have tools that help us graph. So we're actually going to use those tools to help us graph these quadratics and kind of look at them. So let's go through this because I don't think it's going to take super long time. This is what we want. We want our friend Desmos here. So what we're going to do is we're going to graph some of these inequalities. So remember, an inequality is just defined by the fact that instead of an equal sign, you have a greater than, less than, greater than or equal to, or less than or equal to sign. So that's what makes it an inequality. All right, so the first inequality that I actually want to look at is, let's do this one, not that one. X equals y squared. Okay, so x equals y squared is kind of like the standard inequality. Let me make my screen a little bigger. There we go. Did I have it written wrong? Oh, yep, I'm saying it wrong. Thanks, Elijah. So at 9 o'clock on Friday morning, y equals x squared. It did sound kind of weird coming out. Y equals x squared is the standard inequality, right? So this is kind of the one that we compare it to. This is the standard parabola. It's kind of the y equals x, you know, y equals x in linear equations is the line that goes up the slope of 1. Y equals x squared is kind of the standard parabola equation. So we're going to leave this up here and we're going to talk about a couple parabolas. So the first one that we want to graph is, I should get my notes out so I don't have to flip back and forth. Y is less than or equal to x squared. Let me pull out my notes here. No, it's not on that page. All right, well, I guess I'll have to flip back and forth. So the first one I want to graph is y is less than negative x squared. So let's try this guy out. No, didn't like that. Y is less than negative x squared. Don't let me do that. Oh, it doesn't like that. Let me start over. Y is less than negative x squared. There we go. Does not like you to copy and paste, apparently. All right, Elijah's telling us about his breakfast. All right, so what do we notice about this? If I leave the two equations up here, our standard equation opens up, right? No surprise there. When we make it negative, it flips across the x-axis. So a negative parabola is going to open down versus opening up, right? We also have a couple things to note. Y is less than negative x squared. So when you just have less than, and you don't have less than or equal to, right? You just have less than, not less than or equal to. When you have that, you're going to see that we've got this dotted line for the border because it's less than what's on this line. It can't actually be what is on the line. That makes sense. So make sure that when you're looking at your graphs, you're observing if it's less than or less than equal to. And in this particular case, y is less than negative x squared, so it's the inside area that's shaded. Now, if you don't have a nice tool like Desmos that will shade in for you, you can always solve which side to shade in based off of like a simple number. So for example, I could pick, okay, well, what happens when, let's see, let's pick x equals 2. So when x equals 2, 2 squared is 4, and it's negative 4. So we want to shade in here at 2, 0. I feel like I'm not explaining this right. let me back up a second. Yeah, that's what I'm like. This is not going well. All right, so if you don't have a nice tool to shade it in, okay, if you just are able to get the graph without the shading, what you want to do, so we're trying to figure out which side to shade. So what's going on here? You want to pick a random point. So let's pick this nice point here. Let's pick 2, 0. And we're going to see if this point is true or not. If this point is true, then that's the side that should get shaded. If this point is not true, then the other side should get shaded. Okay, so what I mean by that is we're going to plug in, okay, when y equals 0, is that less than negative 2 squared? Well, negative 2 squared is negative 4. So is negative 4 greater than 0? No, this is not a true point. So that means that this is not the part that should get shaded in. The inverse of that is if we would have picked like maybe here, right? This point is 0, negative 2. Okay, so our equation is y is less than negative x squared. Okay, x is 0 and y is negative 2. So negative 2 is less than negative 0 squared, or basically negative 2 is less than 0. So this point is true, right? So that means that this is the part that gets shaded. Just explaining the why of how Desmos works. I know you all can put things in Desmos and see them graphed, but that's why the inside of this parabola gets shaded. Now, if, for example, if you would flip the inequality and you would do y is greater than negative x squared, and let's turn off the blue one. Okay, so you can see the difference. Now, all of the points, since y is greater than negative x squared, all of the points outside the parabola would be true. So Elijah says, so you would just keep doing points till you get one true. Yeah, so Elijah, you want to pick one that's clearly either inside the parabola or clearly outside the parabola, and preferably an easy one with a 0 in it. So one on the x or y axis. But you don't have to do, once you've figured out one point is true or not, then it's okay. My question, oh, so if you wanted to do the parabola without Desmos, Yes, manually drawing a parabola. Parabolas are a little bit trickier to draw, but completely possible. Okay, so if I wanted to graph this parabola without Desmos, what you would do is you would say, nope, there's no formula for it. You would just actually have to make like a little, like we're doing the green one, you'd have to make a little chart. So you'd say, okay, when x is 0, and what you actually would do to graph the parabola is you would make it equal and then figure out the shading. So when x equals 0, y equals 0. When x equals 1, y equals -1. Yeah, when x equals 2, y equals -4. Yep, you just make a table. So then if I graph these points, you get 0, 0, x equals 1, y equals -1, x equals 1, y equals -1, x equals 2, y equals -4, x equals 2, y equals -4, and so on. So when you graph a parabola, when you graph a line, you really only need 2 points, but I recommend 3 points. When you graph a parabola, you kind of need 4 or 5 points, right? You can probably tell this is the vertex, but I would probably pick like a negative number. So I'd say, okay, let's also do -1. So when x equals -1, y equals -1, and then you can kind of sketch from there. So if you were doing this completely manually without any tools, what you would do, first you would make this chart and find the x and y when they're equal to each other. Then you have to figure out this. I kind of flip-flopped how to do it. Then you would have to figure out which side to shade in based off of your inequality. Okay. Does everybody understand that? Fascinating, right? Or you can just type it in your Desmos, but that's not always the case, right? Sometimes you have to know how to do it without the calculator. You don't think yeah. They're probably not going to let you use Desmos on the ACT. However, if you would like to borrow my graphing calculator, you are welcome to do that. That offer stands for anyone. I think they let you use a graphing calculator for the ACT. So yes, that offer stands for anyone on the call. If you ever need a graphing calculator to borrow, I'm willing to let you borrow my calculator, because they will not let you use Desmos, I can tell you that. So that's a good question, actually. How would you do this if you had a graphing calculator? And what you would do is graphing calculators can kind of graph inequalities, not as well as Desmos. They don't shade it in nicely. Most likely, if you were using a graphing calculator, you would actually have to use y equals -x² and then figure out the shading. Okay. All right, so let's do a few more of these. That was kind of the over-explaining for the first one, right? So let's graph a few more and kind of, we're just going to observe. So we've got, whoa, that's a big one. Y is less than -2. Let's see if it'll let me copy it. It would be really nice if it did, isn't it? I don't think it's going to let me copy it. Y is less than -2. I'm just being, yeah, it's not going to like that. I got too many spaces in there. All right, there we go. Apparently doesn't like when you copy and paste. So here we go. Here we have another example of a parabola. This one opens down as well, which shouldn't be too much of a surprise that it opens down because it has a negative in front of the x squared. Oh, yeah, I was just reading Elijah's notes. Yeah. So the negative, Elijah, actually in front of the x squared tells you whether the parabola is going to open up or down. If we make it, for example, if we made this positive, then it's going to open up. And the negative makes it open down. Okay. So the negative doesn't have to do with the shading. It has to do with how the parabola opens up or down. The shading is all based off of, are the values inside the parabola the ones that are true, or the values outside the parabola the ones that are true? Okay, so for example, this is where you could pick a really, really easy point. So just to double check Desmos, not that we doubt Desmos, right? But just to double check that it's right. No, purple's not going to work. This point here, 0, 0, right now is shaded in. So that means that 0, 0 should be a valid answer, right? Does everybody agree with that? That 0, 0 should be a valid answer to the purple equation because it's in the shaded area. So just to kind of take a step back and remind you, anything that's shaded means true. Anything that's not shaded means it's not true for this inequality. So that's what the shading means. If I really want you to understand. I know you guys can all type things in the computer. You don't even need me to teach you that. But I want you to understand what it actually means. So anything shaded should be true. So that means that 0, 0 is shaded in. So that means that 0, 0 should be a valid solution for this. So if y equals 0, is 0 greater than -2 times 0, which is 0, plus 9 times 0, which is 0, minus 4. So is 0 greater than -4? And the answer is yes, right? That's a true inequality. So the Desmos obviously did it okay, but this makes sense that this 0, 0 should be the part that's shaded in. Now, if we picked 1, 2, 3, 3, 0 right here, and we plugged it in, and I'm not going to do that because you're going to have to wait for a while for me to do that. But if we picked 3, 0 and we plugged it in, it's going to be not true. Okay, so that's what the shading means. Again, we've got the dashed lines, so anything along the dashed lines is not going to be true. So for example, 4, 0 right here, if I plug that in, it's going to be equal, but we have an inequality, and so y has to be greater than the other side. All right, since it's a parabola, isn't the answer... Okay, well, not just since it's a parabola, Elijah, but Elijah's saying isn't it any number? It's any point that's in this purple shaded area. So anything that's not in the white area or on the dotted line is true for this purple equation. So you could pick this point out here, whatever this is out here. -10, -5, that's true. You could pick this point up here, 5, 5, that's true for the equation. You could pick a random decimal, point out here, that's true. Because it opens downward, y can have any value. Yeah, you're always going to be able to find a value outside of the shaded area. So if you pick x equals -100,000 way out here, right? As long as you picked y equals 0, then it's going to be true. Eventually, there's going to be some point at which it won't be. Okay, so is everybody following along as what I know you guys can type it in, but as what you're typing in, what it actually means? That kind of makes sense? You got lost. Lost on the what we're doing or on the undefined? What are we all writing down? Oh, no, I'm just saying, I know you guys can all type it in to Desmos and give me a nice, pretty graph. I have all the confidence in you guys to be able to plug all of these equations in and copy them down. I just want you to understand what they actually mean. Like what you're actually punching the numbers in and getting. You know, it's the teacher that's like, hey, I want you to understand why you're doing it. All right, so let's go through a few more of these pretty quickly. Okay. All right, so that was just graphing. What happens if we have two inequalities to graph? It's the same as if we have two lines. It actually makes some really, really pretty graphs for us. So let me actually make this smaller so I can see. Oh, there we go. Okay, so if I have two inequalities to graph, come on, make my window a little smaller. Sorry for all the clicking. What you're trying to do when you have two inequalities is you're trying to figure out. I'm having technical issues today. Just let me look at both, Desmos. There we go. Okay, so I'm doing problem number 3. So we have y is greater than or equal to 2x squared. So that's going to be a parabola that opens up, right? Ooh, black parabola. Okay, and then we've got y is less than negative x squared plus 1. Okay, so we've got our two parabolas that I just graphed. And what you want to do to actually solve this, so what we're trying to do is to find, no, nothing to do with that. What we're trying to do is to find where both parabolas are true. Okay, so it's where both parabolas intersect. So if I wanted to draw the set of solutions that are true for both of these, what you would actually draw is you would draw a dotted line here, right? And you would draw a solid line here. You can draw, right? And you would shade in this tiny little area right here where both parabolas are true. So what this means is that only the values that are right inside of here are true for both inequalities. Okay, so one particular one is 0, 0. This one should be true for both because it's on a solid line. So when y equals 0, is 0 greater than or equal to 0? Yes. Is 0 less than 0 plus 1? Yes. So this is a valid point, is 0, 0. You can also keep zooming in here and pick any point. Desmos will let me. Pick any point that's inside of this equation. So here's a question for you. What about when x equals 0, y equals 1? Is that a valid point to both of these inequalities? So this point at the top of the bottom parabola. James says no. Elijah says technically. So James, get the point on this one. So this is actually not a valid point because the top line is the dotted line. Yeah. And the dotted line means it can't actually be what's on the line, right? It has to be below that. So if we picked x equals 0, y equals 0.5. I know, I told you it was a tricky one, right? X equals 0, y equals 0.5. That would be true for both of them. So this actually has a really small area that's true for both of them. You're going to stick with 0.5. Yep. That one will work. 0 and 0.5 will work for both of them. Or 0, 0, or some little points in there. So that's how you graph two two inequalities and see if they're equal. Clear that off. Okay, so then we have number 4, which you're just going to graph the same way. You're going to see which one's both true. I can go ahead and graph that if you'd like to see. If Desmos will let me look at both things at once. So 4 is y is greater than 3x squared, not to the 32 power, that'd be crazy. 3x squared plus 3x minus 5. And we have that y is less than negative x squared plus 5x plus 10. Okay, so this has a much larger area that both of them share, as you can see as I'm zooming out here, right? So in this particular case, what you would want to do is you would want to highlight the area where they both intersect and not do that. So it's going to be a really weird shaped, it's got a parabola edge here, and I can't even draw. And then we've got a parabola edge here. And so it's going to be this area where they intersect, where they're both true. So again, what about 0, 0? Is this true for both equations? Yeah, 0, 0 works for both of them, right? It's right in the middle of that. So that's easy peasy. What about, here I'm moving along this, I'm trying to look for a nice easy number. There's not one. What about 1.17 and 2.616, this number that's right along the parabola? Is that a valid solution to both? Nope. Yeah, that's right, James. It's not, because it's all on the dotted line, so it can't be true. Okay. So one last thing I want to show you guys is about solving. So this gets back to our fun quadratic equations. Yay, quadratic equations. So if I said solve this by graphing x squared plus 8x is less than or equal to negative 7. I'm going to actually do this in a different way and clear that off. I'm going to actually move over the negative 7 to the other side of the equation. So what I'm going to say is x squared plus 8x plus 7 is less than or equal to 0. Okay, so what I did is I just moved this negative x to the other side of the equation. You guys all right with that? I just added 7 to both sides of the equation. Okay, so technically what this equation has that the other equations don't have, if you notice 1 through 4, we have y is, less than or equal to x squared or greater than or equal to x squared. What you'll notice about 5 and 6 is that there is no y term. So really what they're looking for is, tell me what x's are true, what x's make this inequality true. Okay, so what I did is I moved my 7 to the other side and I graphed it as x squared plus 8x plus 7 is less than or equal to 0. And I'll show you why I did that in a minute. Okay, so now let's go back to Desmos, get rid of all this other crazy screens. Okay, so what I'm really trying to do, if I zoom in a little bit here, first I'll zoom out so you can see the parabola. Can't even see the parabola. It's like humongous parabola. Okay, so that's not going to help me out too much. But really what I care about is I want to know, sorry, it's not fun to watch people scroll on the screen. What I want to know is what x's make this equation true, because I don't have any y values to it, right? So what x's make this equation true? If I were to graph this, it's going to be between x equals -7 and x equals -1, and all of these points in between make this equation true. So if I wanted to write that out algebraically, I would say that, so this is -7 and -1, right? So x needs to be less than or equal to -1, and it needs to be greater than or equal to -7 to make this equation true. You guys following okay? So if I put in, for example, if I put in x equals negative, let's see, -2, which is a point right here, right? Yeah, x equals -2 to my equation, then this should be true. So it should be -2 squared plus 8 times -2 plus 7 is less than or equal to 0. So let's see if this is true. -2 squared is 4, plus 8 times -2 is -16, plus 7. So 4 plus 7 is 11, plus -16, we get -5 is less than or equal to 0. So that shows us that x equals 2 is a valid solution to my equation. So it's a little bit different twist on just graphing the equation and seeing what's true. We're not necessarily just saying that everything shaded in is true. We're trying to find the values of x that makes this equation true. We really don't care about what y value is because in this particular equation, we don't have a y value. So if I would take this and I would graph the same inequality, but I would flip the sign. So let's make it, instead of less than, we make it greater than. Greater than. Okay. So that would mean in order for my green equation to be true, it's not going to be the numbers of x that are on the blue line. It's going to be the numbers of x. I'll have to make it brown. That go this way or this way. So for example, x equals 0 would be a valid solution to the green equation. X equals 10 would be a valid solution. X equals -10 would be a valid solution. So you guys see how you still use Desmos, but it's a little bit of a different flip on how to solve the quadratic equation. Do you want to see one more like that? Yeah, interesting. It's a little bit of a twist, right? So let's see one more that's like that. Actually, let's do one. Let's do one in your book instead. If I can get there, let's see. What number do I have? You don't do 35. Okay. All right, so let's look at number 41. Okay. So it says, I'm on page 305 in your book. It says solve the inequality by graphing. So what we're doing is these equations do not have an y value. So what we're only worried about is the x value, what makes both of them true. Okay. So number 41 is, this is number 41 from your book, is -6x squared plus 19x x is greater than or equal to 10. So the first thing that you want to do when you do this graphing, you can graph the inequality like that, but well, let me show you what happens when you do that. So if I just type this into Desmos like it's written, okay, if I do that, I get an inequality, but it might not necessarily be in the same way. Let's see, if I switch to my 0 on the other side. Minus 10. I guess it does work in Desmos. I always flip it to the other side. It's just a habit from using my graphing calculator. So Desmos is smart enough to know to do it the same way. All right, so I guess you can just type it in like that in Desmos. All right, so what I like to do is flip it to the other side because I think it makes more sense because you're trying to go along the 0 axis and not the 10 axis, the positive 10. So I would actually move your 10 to the other side before you're graphing it, but I guess Desmos works it out for you. All right, so side note there. So now what we want to find out is, what we're really trying to find out, right, is what x's makes this inequality true or this inequality true. They're the same inequality. So the x's that make this true are the ones that are in between these 2 points here. Okay, so 0, right, x equals 0 would not work. If I plug this in, 0 plus 0, negative 10 is not greater than 0. So 0 doesn't work. So it's the inside shaded area that's true. And if I wanted to write this as a inequality, what I would say is, or if I wrote it as a number line, first off, right? If I wrote it as a number line, I would draw it like this, right? If I wrote it as an inequality, I would say that we have 0.0, if my pen will let me write. We have x and we have 2.5. So x is less than or equal to 2.5, but it's greater than or equal to 0.667 or 2/3. Right? So these would be the values that make this original equation true as an inequality. So Elijah said, so basically it is a double-sided equals equation with the cap. Yep. Or Elijah, it could be on the other side. So let me see if I have one. Hold on, give me 1 second. Because I want to make sure that we get it. So it could actually be the outside values that are true. So the 2 examples I did, the inside values were the true values, right? It could actually be the outside values that are true, if that makes sense, outside of the parabola. Okay. All right, so does that make sense for everybody? Not too hard. Desmos still helps you out. Yeah. Yeah, so Elijah, just to follow up on your question, let's do number 37 really quickly. So 37 in your book says and they have this written with the 0. I always think it's better to graph based off 0. I just think that you're always safe if you have a 0 value versus on the other side. They already put it in 0 form, so we're good. Okay, so number 37 is x squared minus 4x plus 2 is greater than 0, right? So what this would be is that the values that are, so if I wanted to graph this on a number line, I would put an open circle right there. I need a different color so it shows up. I would put an open circle at, what is that, 3.5? And an open circle at, I think that's 0.5. And then it would be all the values that are greater or less than. And you can use Desmos to identify this. Oh no, these points are even smaller than that. Yeah. So you can use Desmos to identify those 2 points for you. Okay, and then if I wanted to write this mathematically, I would say that x has to be less than 0.586, if I can write, or x has to be, and then you would say, or x is greater than 3.414 in this particular case. So, yep, not too bad, right? So easy point, right? When x equals 0, 0 minus 0 plus 2. 2 is greater than 1, so that's true. And then you could say when x equals 4, is it true? Straightforward. I like it, Elijah. All right, well, that is graphing in 4.9. I think it's a good section. Like I said, I wanted you to more understand what you're graphing than actually how to plug in the numbers. I'm sure that that will come easily to you. Elijah had a couple questions on 4.6 and 4.8. And if there's any other questions, I have, 15 more minutes to go over anything. And if you are good, then you are welcome to head out. So Elijah, what problems did you want to go over? Okay, she said number 27 from 4.6 and basically anything from 4.8. Well, let's start 27 and 4.6. Okay. And understand how to divide it. Okay, well, let's do 27. Let me clear all this off. Bust out paint here. So 27, Elijah, is 8 minus 3i in parentheses times 8 plus 3i in parentheses. Is that right? This is in page 208 or 280, if I don't reverse my numbers. Is this the right one, Elijah? You think? Okay. Well, we'll do this one and then we'll do one of the dividing ones. How's that sound? So the weird thing, I get it that imaginary numbers are weird. The weird thing that you can kind of do with imaginary numbers is that you kind of treat them like a variable and you kind of, but you know what the variable is. It's always, I is always the square root of -1. But when you're using I in equations, you kind of treat it like a variable. So if you think of this I kind of like an X, how would I solve this? How would I simplify this? And it comes back to your good friend FOIL. Oh yeah, that's right. It's FOIL. Got to FOIL this guy to simplify it. I know. Right. Okay, so we're going to FOIL this just like we would FOIL an equation with X in it. So we're going to do first. So 8 times 8 is 64. Okay, we're going to do outside. 8 times 3i is going to give you 24i. Okay, inside is negative 3i times 8 is negative 24i. And then last is negative 3i times positive 3y. So you're going to get negative 9i squared. Okay. Again, you're kind of treating I like a variable, like an X or a Y. So when we have positive 24i and negative 24i, they cancel each other out, right? It's just like adding 24x minus 24x. So we're left over with 64 minus 9i squared. Okay. Now, I squared is one of those special things. So I equals negative square root of 1. I squared equals -1. Okay, so if I plug in -1 over here, I get 64 minus 9 times -1, or 64 plus 9, or 73. So that's why if you probably looked in the back of your book, you're like, what? It doesn't, how'd they get rid of the I? Right? They got rid of the I by using the fact that the middle terms, the inside outside canceled out, and the squared equals -1. Yeah, there was a lot of things that could trip you up on that one. That's for sure. Okay, so then you said anything that has to do with dividing, right? Okay, so what problem do you go to in that section? 4, 6. Do you know which one problem you go to? I don't need, let me look here. I might have more notes here. Oh, you don't have to go past, yeah, you don't have to go past 29. You just have to do 3 through 27. But I'd be happy to do 29 if you'd like me to. Yeah, 4, 6 says 3 through 27 odd. But I'm happy to do it if you want to see how to divide by it. Your note says 3 through 33 odd. Really? Are you in 4, 5 or 4, 6? 4, 5 is 3 through 13 and 23 through 33. And 4, 7 is 3 through 33, but we're not doing 4, 7. So if you made it to 27 in 4, 6, then you're done. With that particular one. All right, 4/8 time. Any particular one? Anything. All right. Let's do number... Let's do number 21. Okay. So 21 is 4 plus 9n minus 3n squared equals 2 minus n. Okay, so remember, in order to use the quadratic equation, I don't know if you have it up next to you somewhere, so you want to keep it next to you. But in order to use the quadratic equation, we have to have it as a squared or ax squared plus bx plus c equals 0. It has to be equal 0. So we can't use this like it is now. So what we need to do is we can send everything to one side. So we could add 3n squared, subtract 9n, and subtract 4. And then we have to do that to both sides. Add 3n squared, subtract 9n, and subtract 4. Kind of doing this a sloppy way, okay? So 0 equals 3n squared, and then negative 9n minus n gives us negative 10n, and negative 4 plus positive 2 is negative 2. Okay, so there's multiple ways that you could do that. You could move these to this side. Either way would work. I was just, yeah, you could totally do that, Elijah. The reason, honestly, I did this is so that I ended up with a positive 3 over here. But probably if you moved everything the other way, did you get negative 3n squared plus positive 10n plus 2? Yep, and that's fine. It'll work out the same when you do your quadratic equation. It was just me not liking the negative numbers. But it'll work fine. Oops, that's not what I want to do. Nope. Not what I want to do. Okay. So now what you want to do is you want to figure out your A, your B, and your C. So A is going to be 3, or in your case, maybe negative 3, right? B is going to be negative 10, and C is going to be negative 2. In your case, those might all be flipped, and that's okay. It'll work out when you do it. So the quadratic is just a plug in, right? X equals, let me make sure I've got my paper here. Okay, X equals negative B. So negative of negative 10 is 10. Negative B plus or minus the square root of negative 10 squared minus 4 times A, which is 3, times negative 2, divided by 2 times 3. Okay, so now you can figure out how you like to do this. You can simplify inside of here. You can use Desmos, and I'm running out of space. So Elijah, I'm going to go up here. So 10 plus or minus, okay, 10 squared is 100. So this is 100. 4 times 3 times negative 2 is 12, 24. So this is going to be, it's going to be 10 plus or minus 124. Yep, awesome. Divided by 6. So this, Elijah, is technically the answer, but I know that we don't really like the answer to look that way, right? I'm pretty sure in the back of the book they're not going to leave it that way. I haven't even looked, honestly. How do they have it written in the back of the book? Oh, in the back of the book, they actually have it kind of written like that. They simplified it a little bit. So they actually leave it as that kind of radical. What they did is they said, oh, well, we can pull some numbers out of this. So technically, this could just be the answer, or you can simplify it into the decimals. So I don't know which is easier for you. So that would be a valid answer, or you could actually type it in your calculator. And what you would type in your calculator is 10 plus the square root of 124 divided by 6, which when I do that, I get 10 plus the square root of 124 divided by 6, I get 3.52 if I plug this into my calculator. And if I do the negative, I get negative 0.189. So, yeah, so what a lot of people want to do when they type it in their calculator is they want to divide the 6 just by the square root. Make sure your 6 is dividing the 10 plus, like, so make sure that's in parentheses. Cool? All right. Well, I actually have to get on with my Algebra 1 students, including your brother. But if you would like any more help, Elijah, later on, yeah, if you want any help, I am available. So, okay. But if you get stuck, let me know, okay? All right. Have a good day. I'll talk to you later, all right? Bye.